Now let's take a look at question on page 13 in our notes. Explain why the following is a redox or not a redox reaction. So you recall that redox reaction is simply a reaction that has oxidation and reduction taking at the same time. Oxidation on one substance whereas reduction on another substance. So let's take a look at the first one, methane plus oxygen producing carbon dioxide and water. Whether is it a redox reaction or not. So let's start off with, we can actually start looking at this oxidation state first. Okay, hydrogen, how do we deduce the oxidation state? It will start off as though each and every one of them is an ion, although they are covalently bond. So hydrogen, that's why you know the oxidation state previously, check in your table. Okay, it's a positive 1. There's 4 hydrogen, so there's 4 of them. 4 times plus 1, so the oxidation state for carbon will be a minus 4. Oxygen is a pure element, so its oxidation state is 0. So that's what we deduce for the reactants. Let's take a look at the products now. Carbon dioxide that contains oxygen atom. So what we know previously, group 6 elements has an oxidation state of minus 2. 2 oxygen atoms in carbon dioxide, so it's 2 times minus 2. That's how I deduce a carbon with oxidation state of plus 4. So that's what we have. Once again, we start with oxygen. Group 6, fixed oxidation state of minus 2. We will ignore, okay, the coefficient in front. Okay, instead we'll just look at there are 2 hydrogen carbons. Therefore, the oxidation state for hydrogen will be plus 1 times 2. Now, next is we compare the elements present. Is there any change? Okay, so we start off with, do you notice carbon? Do you notice anything about oxygen? We start off with oxygen. It's being reduced as its oxidation state is 0 and to minus 2, which is consistent for both oxygen. So there is a reduction in the oxidation state from 0 to minus 2. So let's talk about the next element, that is or the next substance, which is methane. Methane is being oxidized. You can either explain this from carbon and hydrogen that makes up methane. It forms your carbon dioxide, so there is a loss of hydrogen, or you can simply say explain it in terms of its oxidation state from minus 4 to a plus 4. Both will be accepted. The oxidation state of carbon changes from minus 4 to plus 4, or is oxidized as it loses hydrogen. So we can deduce that, is it a redox? There's a reduction taking place, there's oxidation reaction taking place. So this is a redox reaction, and this is what we call a combustion reaction. Next, we have the next equation. Sodium hydroxide reacting with hydrochloric acid, forming your sodium chloride and water. Once again, we start off with looking at this oxidation state. We work with oxygen. Since you know it's group 6, it has a minus 2. Hydrogen, positive 1. So minus 2, positive 1. Recall that the entire compound has to have an oxidation state of 0. So sodium will take the oxidation state of plus 1. Hydrogen, we already know, is a positive 1. Chlorine will be a negative 1. Same over here. Sodium, group 1, positive 1. Chlorine, group 7, negative 1. And hydrogen, there's 2 of them. Each one atom will take, the hydrogen ion will take an oxidation state of plus 1 multiplied by 2 since there's 2 hydrogen, and oxygen of minus 2. So we have written down the oxidation state. Let's do a comparison. We can compare sodium. Is there any change? Plus 1, it remains as plus 1. Oxygen, minus 2 remains as minus 2. Hydrogen remains as positive 1. And lastly, chlorine remains F minus 1. So as what we have found out, it is not a redox reaction as there is no change in oxidation state. It's a neutralization reaction instead.